Stan Gibilisco here, proprietor and operator of amateur radio station W1GV Whiskey 1 Good Vibrations. Here with a little idea that I thought up. I don't know whether it's possible or whether it's impossible, but it's at least fun to imagine. It's called Hyperspace Communications. The same thing as certain science fiction shows may have described as subspace communications or something similar. Suppose that space, our three-dimensional universe, represented by this blue line here, is curved, particularly in the vicinity of gravitational sources, as Einstein describes in his general theory of relativity. And suppose then that it's curved, of course, with respect to at least one more dimension. Suppose four-dimensional space. A straight path, then, through four-dimensional space between two locations x and y, or QTHs, x and y, would be shorter than the distance in three-dimensional space because of the curvature. The curved path between 2 points, well, you know, the shortest path between 2 points is a straight line. But what is a straight line? That is the 64 quadrillion Quatlu question. A straight line is what looks straight in the number of dimensions in which you exist. So in three-dimensional space, the path between locations x and y would look like a straight line, but in four-dimensional space it wouldn't. It would look curved. You'd have to the four-dimensional straight line would be shorter, a shorter path. So, assuming that the speed of light, c, is the same in four-dimensional space and in any number of dimensions, then the time it takes for the signal, for any signal to get through a four-dimensional space between the locations, is shorter or less than the time required for the signal to get through three-dimensional space. Now suppose that further that space continues to have an increasing number of dimensions, that in fact there exist infinitely many dimensions, and that so you could have 5 or 6 or 7, and by dimensions I mean as described by perpendicular axes, such as the familiar XYZ space. You know that old geometry stuff that you learned in high school. Coordinate x goes along an axis that's a straight line that you might describe as horizontal. Coordinate y goes along an axis that describes something that you might describe as moving towards you, towards away from you, or towards or away from you, and axis z moves vertically. And they're all at right angles to each other. In three-dimensional space, you can only have 3 of these axes. In four-dimensional space, you could have a fourth one, which cannot be rendered in any conventional means by any type of illustration that I know of. I had a weird dream once that I was in fourth dimension, in the fourth dimension or in four-dimensional space, and that I actually could imagine it. But of course, the instant I woke up, that little bit of magic disappeared. But suppose now instead that we're going through four-dimensional space and we decide that we want to follow a path through five-dimensional space. Well then, the path presumably in five-dimensional space, if four-dimensional space is curved, would be shorter still than the path from x to y in four-dimensional space. And it would continue to get shorter and shorter and shorter, and therefore the propagation time smaller and smaller and smaller as you increased the number of dimensions indefinitely. So you might have, say, well, let's use the letter Q here. Q dimensional space. That doesn't sound very good, does it? Let's say, Q will do. Q dimensional space is curved with respect to Q plus 1 dimensional space. So, as you increase the value of Q, the meaning of a straight line changes. With respect to Q plus 1 dimensional space, a straight line is longer than it is it's shorter than it is with respect to Q dimensional space. And so as the number of dimensions, that is Q, approaches infinity dimensional space, as the number of dimensions approaches infinity, then the distance d between these 2 points, let's say d sub q and d sub q plus 1, these values of d approach 0. So, if you could get somehow a signal through infinite dimensional space, then it wouldn't take any time at all for that signal to get from location X to location Y. The length of time that it takes for the signal to get from X to Y would approach 0. So in absolute ultimate hyperspace, infinite dimensional space, infinity space, you could talk to someone anywhere else in the universe with 0 propagation delay. And that makes for great science fiction. But suppose that it's actually science fact that we simply haven't discovered yet. How much do you want to bet that the person who does discover it, if it exists, is a ham radio operator? Stan Gibilisco, W1GV, signing off, saying 73, which means, of course, best regards, and so long, which, through hyperspace communications or ordinary communications, or in any number of dimensions, always shall translate in my native fist as da-da-da-da-da-da.